Dear all, in this video I will be discussing some important concept on sum of product and product of sums in digital electronics which can be expected for various competitive examination. So I will be discussing the concept in brief. Based on the concept, I am going to discuss few important questions which can able to ask in the forthcoming examination. You know what is SOP? SOP is nothing but sum of product. It is one of the method of simplifying the Boolian expression, or you can call the logic gates. Okay, simplification of Boolian expressions of logic gate, one of the method. And the thing is, it is one of the representation or a notation of writing the Boolean expression. As the name implies, it is formed by adding the product terms. Adding means or. Let me give one example. So consider the expression f is equal to a dash bc plus a b dash c plus a b c dash plus a b c. This is an expression. So this is one of the example of sum of product. Why do you call it as a sum of products? Because you can see these are the sum. Wherever the sum is there, you can call OR gate. OR gate should be there. Here one OR gate, and at this point also one OR gate must be there. Here also you can able to see OR gate. And in between a dash bc there will be one AND gate. Look at this. Here also there will be AND gates. Okay, dot which I mentioned, there will be always an AND gate. So this notation is generally known as sum of product. It is also the term which is belong to sum of product is called min terms, which is denoted by the small letter m. Okay, so we need OR gate and AND gate here. Okay, this is the way how to represent sum of product. Look at an example. This example depicts how to write the sum of product. There is a truth table. ABC are the input and X is the output. You can able to see how we can able to represent sum of product. Now do one thing. Wherever you are getting the output high, you take care only that points. Here I have to take care. And wherever I am getting the high output, you please consider that particular point. Now look at this. So this is belong to number of 1. Okay, all are decimal number only 1. Next this must be 3, clear, and this should be 6. All are decimal numbers only. Now I can represent x of SOP is equal to sigma m. Small letter m means min terms 1, 3, 6. Now you try to simplify only that terms, like this is a dash, then what I can write, this must be b dash and c. So this should be b dash, like this. Now a dash bc, and this will be we can write a b c dash. And suppose if there are n variables, now how many variables are there? N variables. Okay, if there are n variables, then corresponding min terms will be 2 to the power n. So for example, if there are 3 variables, obviously the number of min terms, that will be 2 to the power 3, that is equal to 8. There are 8 min terms must be there. You can remember in that manner. This can be expected in the competitive examination. Similarly, there is one more method that is called product of sum. It is known as POS. The sum term is also known as, the product of sum is also known as max term, which is denoted by the letter capital letter M. As the name suggests, it is formed by multiplying the sum of terms. Look at this. Multiplying, these are the sum of terms, a plus b plus c. Here OR gates are required here. OR gate, just opposite to that of min term. You can see these are the OR gates. Now what you do, you are multiplying the what we can write is multiplying the sum terms. So these are the sum terms. You can see sum terms. You are multiplying the sum terms. Okay, this is known as max terms or product of sums. The max terms are represented by uppercase M. They are the sum operation of Boolean variable either in normal form or complemented form. Okay, I hope you understood. This is the way how to represent product of sum. Now I'll show you one simple example so that you will understand the concept very clearly. ABC are the input and X is the output. Now do one thing, how to represent POS. Now you take care wherever the output is 0. Look at this. Okay, wherever the output is 0, you can able to concentrate. Okay, and the thing is, the POS can be written, POS x POS, that can be written as the pi m, capital letter M. The first point is 0, the second point is 2, next is fourth point, then fifth point and seventh point. Okay, now we can able to write corresponding the first number, we can able to write, look at this, A B C, A B C. Next what you do, second point, A B bar C, then fourth one, this is the fourth point, A bar B C, then fifth point you can see A bar or A dash plus B plus C dash. Now you can able to see the last term, A bar B plus B bar plus C bar. Likewise you can just verify. So wherever 1 is there, you take the complement. Wherever 0 is there, you take the normal term only. Likewise. So this is the way how to represent POS. I hope you understood how to represent POS. These are the difference between SOP and POS. Now there is a table which indicates the difference between sum of product and product of sum. Number 1, sum of product is the way of representing Boolean expression as the sum of product terms, where POS is the product of sum terms. Now SOP uses min terms and where POS uses max terms. So min term is the product of Boolean variables either in normal form or complemented form, where max term is the sum of Boolean variables either in normal form or complemented form. That is true. And next point is, it is a sum of min terms, and where POS is the product of min terms, and SOP is represented by the small letter m, where POS is represented by using capital letter M. And also SOP is the form by considering all the min terms whose output is high. You see the truth table which I have shown you. I have considered only where you are getting the high output. That means 1. If I talk about POS, POS is formed by considering all the min terms whose output is low. Then I have taken the equation. While writing the min terms for SOP, the input value 1 is considered as variable itself, and the input with the value 0 is considered as complement of the input. So where in case of POS, input value 1 is considered as complement. Note down this point, very important. And the input with the value 0 considered as variable itself. I hope it is very clear. I have explained with the help of that particular MCQ. Now what I am going to do is, I will be showing you some numerical example, some objective questions. So kindly answer it. Okay, you can able to answer it properly. Afterwards you can verify the answer, is it correct or not. So all questions which I discussed, all concept I have discussed, but questions are yet to discuss. Okay, so there are 6 questions, you know. Yeah. Now let's start discussion. Number 1, the term SOP is called, obviously the B is the right answer, min terms, where POS means you would have been selected as max terms. So now the right answer is min term. Hope the answer is correct. Now which of the following is incorrect SOP expression? Incorrect SOP expression. Which is the right answer? SOP means sum of product, right? Sum of product. So which is the right answer? Incorrect, underline. So this is actually incorrect answer. It would have been written as product of sum actually. This is product of sum. Hope you understood. Always people are getting confusion about sum of product and product of sum, so don't make the mistake. Which operation shown the following expression? It would be obviously a product of sum. Look at this product. These are the product. Here AND gates are required. Here OR gates. Okay, product of sum. Now the number of min terms in an expression comprises of 3 variables. Use the formula 2 to the power 3, that is nothing but 8. Okay, there are 8 variables. It is written over the last 5th question. The output of AND gate in the SOP expression is connected using -1. OR gate, obviously. You should know the difference between SOP and POS. That if you write one equation, definitely you will come to know. The output of AND gates in SOP expression is connected by using OR gate. Last question, the expression for ABC is in the form of A